Building a solar-powered night light. Chapter 1. Solar Power Generation Technology. What is solar energy? Solar energy is energy provided by the sun, in the form of solar radiation, that makes solar electricity production possible. There are two main ways to convert this energy into electricity: directly, through the use of photovoltaics, PV, cells, or indirectly, using concentrated solar power, CSP, systems. PV cells are made from materials that exhibit the photovoltaic effect when sunlight hits them, causing electrons to flow and generate electricity. These cells produce direct current, DC, power, which must be converted to alternating current, AC, for practical use. CSP systems use lenses or mirrors to focus a large area of sunlight into a small beam. Determining power consumption demands. In determining the power consumption demands, you will be able to estimate the amount of energy needed to be supplied by the solar PV system. 1. Calculate the total watt-hours per day for each appliance used. A. Make a list of all the appliance and/or loads that you are going to run using the PV system. To determine the wattage, most appliances have a label on the back that indicates the wattage. Specification sheets, local appliance dealers, and the product manufacturers can also be used as reference. B. Add the watt-hours needed for all appliances together to get the total watt-hours per day which must be delivered to the appliances. 2. Calculate total watt-hours per day needed from the PV modules. After determining the total watt-hours per day, multiply it by 1.3, the energy lost in the system. In doing so, you'll be able to get the total watt-hours per day that needs to be provided by the panels. Sizing the PV modules. Sizing the PV modules will help you find out the appropriate size of PV module that will produce an amount of power suitable for your daily consumption. To find out the sizing of the PV module, you need the total peak watt produced needs. The peak watt, WP, produced depends on the size of the PV module and climate of the site location. 1. Calculate the watt peak rating needed for PV modules. To get the total watt peak rating needed for the PV panels needed to operate the appliances, you will need to divide the total watt-hours per day needed from the PV modules by 3.43. 2. Calculate the number of PV panels for the system. After getting the watt peak rating needed for PV modules, divide it by the rated output watt peak of the PV modules available to you. If the answer resulted to any fractional part, just increase it to the next highest whole number. The answer you got will be the number of PV modules required. Battery sizing. A deep cycle battery is recommended to be used in PV systems. It is specifically designed to be discharged to low energy level and rapid recharged or cycle charged and discharged day after day for years. Make sure that the battery is large enough to store enough energy to operate the appliances even at night and cloudy days. Follow these steps to find out the size of the battery. 1. Calculate the total watt-hours per day used by appliances. 2. Divide the total watt-hours per day used by 0.85 for battery loss. 3. Divide your answer from the previous step by 0.6 for depth of discharge. 4. Divide your answer from the previous step by the nominal battery voltage. 5. Multiply your answer from the previous step with days of autonomy or the number of days that you need the system to operate when there is no power produced by PV panels. In doing so, you'll get the required ampere-hour capacity of the deep cycle battery. Solar charge controller sizing. A solar charge controller is a device that regulates the voltage and current coming from the solar panels to the battery. It is essential to match the controller's amperage and voltage ratings with that of your PV array and battery. When selecting a solar charge controller, it is important to determine the voltage of your PV array and batteries and then decide which type of controller is suitable for your system. It is also important to ensure that the controller has sufficient capacity to handle the current from the PV array. Move to Chapter 2 for more relevant discussions.